Hi everyone, today we're starting lesson 3.1, the first lesson in our next chapter about quadratics. And first we are going to talk about transformations of quadratics. You will recall from our first chapter that we learned about transformations of parent functions, quadratics included. So today's lesson is a little bit of a review, but we are going to expand on it from here. So if we look at the equation for a quadratic, for a parabola, the basic equation in vertex form is that f of x is equal to a times, in parentheses, x minus h squared plus k. And that a could have a negative on it, which would be a reflection in the x-axis, or it could be a vertical stretch or shrink, whatever the number is. If it's bigger than 1, it's a stretch. If it's smaller than 1, it's a shrink. We can also use h to translate left and right. Remember that that's horizontal inside with x, and so it goes the opposite of what we think it would because of this negative sign right here. And then finally, if we have a number that's added or subtracted at the tail end, that's a translation up or down. In this form, the reason it's called vertex form is because the vertex is very easy to pick out. The vertex is at h, comma, k. That's the x and the y value. So let's take a look at some examples and see if we can practice picking out the vertex, the h and the k. So again, remembering that our vertex form has a negative built into the equation. So there is a negative in the equation. So that means if we see a negative number, it's actually a positive h. So in this case, this negative 2 means that we have a value of positive 2 for our h value. Our k value, well, there's not anything out at the end, so it's kind of like a plus 0. So our k value is just 0. The second one, we see a positive sign here. Remember that you need to think opposite, so your h is actually a negative 3. K is negative 1. Pause the video here and see if you can do number 3 and 4. Then come back and check your work. All right, so remembering that a positive that you see is a negative in the vertex, we get a negative 2 and 4 for our vertex for number 3. And again here, the positive indicates that the actual vertex is negative. And so we have a negative 3 and a 1.